So now we're gonna move to number B, where we're actually going to talk about a current in a current carrying loop. Here we spoke about the current in a linear conductor, straight line, just like this, which is, I took it from here. Oh, by the way, I think this is what I wanna do. Here, here, number A. You can also introduce this. Let me do it here. It's fine. Let me do it here. I think I'm forgetting, but it's not. If you understand this, you can also do that. Just that I just wanna show it. Let me show it. Even if a current it is moving from A to C, it is still a straight line, right? But how to analyze the directions here, A to C. So A to C, A to C, A to C. I'm not gonna take it the reverse, I'll just take A to C only. A to C, ne? A to C, you still use your right hand. But this is how you're gonna point your finger, right? Uh, this is how you're gonna point your finger because it's moving from A to C. Twist that finger. If twist that hand, if you have to break it, Shane. So if the current is moving from A to C, magnetic field over here is gonna be a little bit different. How we gonna read the magnetic field? So here it's simple, ne? How do we determine? Let's start by talking about the direction of the current first, right? As much as we did over there. Direction of the current here, we're not gonna say it is into the page. We're not gonna say it is out of the page. We're not gonna say it's moving away. We're not gonna say it's moving towards. Here, we're gonna say the current, it is simply moving using the thumb pointing in this direction. We're gonna say the current, it is moving to the right. Simple, the current, it is moving to the right. So I mean the current here is moving to the right. To the right. Then, let's talk about the magnetic field. So magnetic field, we can't use clockwise or anti-clockwise here. If the current is moving to the right, let me go back to my fingers there. If the current is moving to the right, let me show you. What's happening? Your fingers, they're gonna go inside of this part and then they're gonna come, you see, they're gonna come outside of this part. They're gonna come outside and then here they're gonna go inside, right? Take your pen and then hold it with your left hand and then put your fingers at the bottom of the pen and curl your fingers so that they come out at the top of your pen. So in that case, we can see that here, the direction of the magnetic field, we're gonna say the direction of the magnetic field at the bottom of the pen. I get this is the top of the pen. At the bottom of the pen, which is this side, we're gonna say the magnetic field is going into the page. Okay, it's going into the page. So when it goes into the page, we're gonna use what? Axis. We're gonna use what? Axis. We're gonna use what? Axis. I think I have this picture over here. Let me see. I think I have that picture over here. This one is under solenoid. It will confuse you. It's fine. Let me leave it. So the picture here, the magnetic field is going into the page, and then your fingers, they're going to appear here at the top. And then when your fingers appear here, what is happening with the magnetic field? It's coming towards you, meaning it is coming towards you. You use the dots. Remember, towards is like an arrow pointing you, looking at you. So that means here the magnetic field is coming out of the page. It's coming out of the page and then moves like this, moves like this, moves like this, moves like this, moves like that. This is into the page, out of the page. Into the page, out of the page. Into the page, out of the page, into the page, out of the page. So in this case, that means our magnetic field at the bottom. So, okay, let me erase this. Let me say this is at the top, at the bottom, it will be I'll name it A, section A, and at the top, I'll name it section C. So that means at section A, magnetic field is denoted by letter B, by the way. Magnetic field is going into the page, which is this, this, this. We use axis, 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 axis. And then at the top, it is moving out of the page. At the top, it is moving out of the page, at C. And then at C, magnetic field, which is denoted by Akira current is I, magnetic field is B. Magnetic field is moving out of the page, or it is moving towards you. You see, they're always looking at you. It's gonna step, it's gonna, yeah, you. And he's moving away from you with that X. So this is how we read the directions when the current current conductor is in this direction. Okay, so be careful about that. So even if the current was moving in that direction backwards, you still do the same thing. You take, if the current was moving like this, you know the drill, Mos. You know that your thumb will face in this direction, right? Your thumb will face in this direction. Go back to that picture. Your thumb will face in that direction. Your thumb will, your thumb will face in this direction. Your thumb will face in this direction, and therefore look at the fingers. The fingers here, they go at the top, they go into the page, into the X, X, X. And then here they come out. You see, at the bottom, they come out. The fingers come out, and therefore we have dots here. It is out of the page. So if the current was moving in this, take your thumb and then put your fingers inside here, and then they come there, because, and therefore this will be, let me see. Oh, sorry, it will move like this. Your fingers will be like this. So your fingers will go here, inside of the page, will be into the page. Will be into the page, this side. And then when your fingers go inside here, they will come out here at the bottom, will be out of the page. I wish I was doing this practical. It's hard teaching this online, but yeah, it's fine. I hope you get the idea. And then that's it. So I want to take questions, concerns, complaints. Do we all understand, guys?
I understand. I have no questions.
Naledi? Naledi?
Abu,
You understand?
ke nahana ke tla understand hantle ha nka shebella video yane ya pele.
Okay. You see, if network, how the problem is your network. Carrying loop. Right. A single loop, by the way. A single loop, by the way. All right. So now, apparently this circuit can be represented like this. Say here we have a loop. It's a loop, right? And here you have maybe positive terminal, we have negative terminal. It's a loop, a single loop. This is a loop. It's a single loop. Instead of a square circuit like this or rectangular circuit like this, you can have a loop like that. So imagine if these loops are many loops, they will form a solenoid. Okay. So, but here we start with a single. That's why they say single loop. So, well, if we have a single loop like this, if we have a single loop like this, My God, my drawing so bad. We have a single loop like this. It's like I'm not doing engineering graphics. So if we have a single loop like this, okay, and then say that here we have a cell still under Faraday, not Faraday, I mean Christian. This concept is under Christian Hansosted, where we power the circuit by electricity. So remember, electricity will move from positive terminal to negative terminal, meaning from positive terminal. So the current will move like this, they will move like that, move like that, this, until it goes to there. There is a current in this circuit, right? In a single loop, right? So now we want to talk about what? We want to talk about the, so what is the in this loop, what is the direction of the current? It's straightforward. It is clockwise. You see, moves like a clock. So we don't even have to stress ourselves. We can see the direction of the current in a loop. It is a clockwise direction in a loop. So that means here current is clockwise. Moves like a clock. I get 12, 1, 2, 3, 4. You see, it's like a clock. It moves like a clock. It's clockwise. Now, what about magnetic field? Refer to this thing again. Use the right hand rule to determine the direction of the magnetic field associated with a current carrying loop of a wire. Ah, good. We come here. So now, to determine the direction of the magnetic field, hey, the very same idea that we used over here, we're still gonna use it, which is for sure the idea that we used over here, here, the idea that we used over here. We're gonna use this idea, okay? So hold your loop. I don't know, you wanna hold it where? However you wanna hold it, let's hold it like this, like here, let's hold it here. Where's your current moving? Your current is like moving in this direction, right? So take, oh my God, take your fingers, né? Make sure that, not me doing it, and you guys are not seeing me. Take your finger, take your right hand to look like this, because current is moving like this. On this portion, on this part, current is that thing. Current is moving. This is the loop, right? This is the loop. Assume that this is a loop. Yes, love it. It makes sense now. This is my hand. So current is moving like this. We can see that, right? Current is moving like this. So remember, I said if the current is moving like this, what's happening with fingers are going in here, this section, fingers are going in and they're gonna come out at the top. They're going in. I get for you, for this thing to make sense, ne? Hold the pen. Take your left hand side, ne? And then hold your pen here. Hold your pen here with your left hand side. Hold it somewhere else here, ne? And then approach this pen with your fingers, with your right hand, ne? Approach your pen. I agree. Here, you're holding it with your left hand. You're holding at the tip with your left hand. And then approach it with your right hand. And see how your right hand is moving while your thumb is pointing like this. And see how your right hand is moving. Your right hand is approaching this side, right? And then immediately when you get to this side, curl your fingers so that they come outside at the top of this loop. They come outside at the top of this loop. Ne? I want you to do that. I hope you're doing the right things, guys. If you're confused, please stop me if you don't understand what I'm saying. So just do that for me. Ne? So you will see that here at the top, your fingers are going inside. I mean, at the bottom, your fingers are going inside. Your four fingers are going inside while the thumb is pointing in this direction. Your four fingers are going inside. So that means here we have an X because it is into the page, inside of the page. And then when you curl your fingers now, your tips of your fingers are going to point at you at this point. So meaning here we can see that we're going to have dot, which is the fingers that are going to point you at you, towards you. Right? Again, you can even take this part. It's like downwards. It's like downwards. You can take downwards. Ne? You can take your downwards. And then your thumb will face in this direction. This is the direction of the current, right? The thumb will face in this direction. But one thing for sure that I know, your fingers here, they're gonna go into the page, and then here they're gonna go out of the page. Practically do it wherever you are sitting so that it makes sense. So if you practically do this inside of this loop, you will see that inside of the loop, you're gonna have into the page. And then outside of the loop, you're gonna have out of the page. All of this outside, you're gonna have out of the page, and then out of the page throughout. So that means your magnetic field will move here and come out here. Move there, come out there. Move there, come out there. I'm trying to form the circles around this. Circle, circle, circle. You see, it will be like that. So meaning at the center of this loop, at position A, which is the center or the inside of the loop, the magnetic field, it is actually going into the page. And then outside of this loop, magnetic field is coming out of the page, is coming towards us, is coming towards us, is coming out of the page. And therefore, it's like this part, it's north, and that part it's south because it's moving out, coming to this direction, moving out, coming in this direction. So it's hard to see this because again, I draw a 2D, I can't draw 3D, so that makes sense. But yeah, nonetheless, this is how we present it. Okay, so that means at point A, let me do this, not to confuse you, so that when you are doing it yourself, you still remember. So here I say it's A. So at A is into the page, and then I'll say B is outside, ne? At B, out of the page. So same applies, even if the loop was like this, and then the current is now moving like this, you see, anti-clockwise. I agree here the current is moving clockwise. The current is moving anti-clockwise. I'm giving you that as homework. Simple, you still use the same idea that I showed you to determine. You see, here is gonna be in, and then there's gonna be outside. You will see that if you do the same thing, you're gonna get different directions of magnetic field. I agree here we're getting into, and then it's out. But here inside is going to be out, and then there's going to be into. It's going to be opposite of this. So you can use the whole idea to figure out the other one. So do we understand the current carrying loop? Do we understand the directions of the magnetic field? Oh, by the way, don't forget here I'm talking about magnetic field. It's B. Okay, I'm talking about magnetic field, current, magnetic field. Even here we spoke about current, magnetic field. By using the right hand throughout, where the thumb represents the direction of even here, the thumb represents the direction of the current, the four curled fingers represent the direction of the magnetic field. Guys, do we understand?
Yes.
So now we're gonna learn a solenoid. We're gonna learn a solenoid. So now again, we're still gonna need to learn, we're gonna talk about the direction of the current, we're gonna talk about the direction of the magnetic field in a solenoid. While we are applying this guy's basic again, Christian Hans Ørsted. But now we have a solenoid. We don't have straight line, we don't have loop, we have a solenoid. So solenoid, oh my God, I'm not good at drawing, but yeah, it's fine, fading. So we're gonna have a solenoid like this, a circuit that has a solenoid like this. So here maybe we have a positive terminal, and then there we have a negative terminal, positive, negative. So current will move like this. And then, oh, it's gonna bore me when it gets to the direction of the current there. Let me check something. So let me see here. I think this, I want a proper picture, because even you guys, it can be confusing at some point, okay? It can really be confusing as well. More especially the pictures that they give to you. So you know what I'm gonna try to do, né? I'll try to draw it so that it makes sense. Look, ne? Follow me. Follow my lead. So this side we have a solenoid, ne? God, I'm not good. Okay, it's fine. So I'll discuss this picture with you so that you can understand what is basically happening. Look, ne? Let me use a different color for current. Let me use this one. So here's the current from positive terminal to negative terminal. So you see my current here, it's moving like this. And then here it's, well, it's moving like this. It's moving here, it's moving here. This is going down. This part ne, is in front. This part where it's moving down in front. And then there it's moving up because it's at the back of a solenoid. And then it's gonna appear here at the top, and then here it's gonna move in front, and then there it's gonna be at the back. And then it goes again, appears at the top, and then here it's moving in front, and there is at the back, it's moving in front, and then at the back of a solenoid, and it appears here again, and then here's the in front, and then at the back, it's moving there, and then here's in front, at the back, and then it appears here, and it moves downwards, downwards, downwards. There. Did you see the direction? Hello? Okay. Just want you to pay attention on that part. So the curled fingers here will represent the direction of the current. Okay? And the thumb here, I'm changing the statement, will represent the direction of the magnetic field. Remember, B is magnetic field. So now look, take your, again, keep reading this thing, glue stick, I don't know, you call it glue stick. It represents your solenoid. Or you can imagine, you can even take your pen and imagine it's a solenoid. It's a solenoid. Ne? Now, this is what is happening. You see where this finger is pointing. You see where this finger is, is it? You see where the thumb is pointing, this part of the thumb. Do I even have it here? No, I don't see. Or maybe I'll explain with this picture. It's fine. I'll explain with this picture. So here's our solenoid. You see, we managed to form. So, but the current, okay, it's fine. The current is moving like this from positive terminal to negative terminal. So the current is moving up here. It's moving up. But there at the back, it is moving up. But here at the top, it is moving down. Here in front of this nail, it is moving down. And it goes at the back of yours, it's going to move up. And then here's going to move down. And then it goes there at the back of the nail, it is moving up so that it appears here and then it's moving down. Now can you see this picture? Okay, so look then, ne? I'm saying to you, the curled fingers is the current, like they say here. And then the thumb will represent the direction of the magnetic field. I don't like this. Direction of the magnetic field. Don't use this. Direction of this thing. So now look. Your fingers here, they're gonna go in. It's X. They're gonna go in. Your fingers here. Current is moving into the page. And then your fingers there, they're gonna appear here like a current. You see, current is gonna appear there at the top so that it goes down. And then here your fingers, the current, it is coming towards you, out of the page. Ne? So when the current is coming out of the page at the top, but here is moving into the page. In front of the solenoid, the current is moving downwards. It's going to be into, at the back, up, at the top, out of the page, in front, down. That's the direction of the current. Current is going to move into the page. At the back of this nail is going up. And then at the top of this nail is going out. And in front of this nail, it is going down. It's a second. You get it? I hope you get it. Okay, that's the current. And then remember, these are the curled fingers, right? Like I said here. These are the curled fingers. You have your curled fingers like this, wrapped around your solenoid, like this. They went into the page and they went out here. And then it was up at the back of the nail, and in front, it was down. Right? Okay. Imagine like your hand is there. And then now look, where is the thumb pointing? Obviously, the thumb is pointing like this. Right? So when the current it is moving down here, that means make sure that your four curled fingers, they act perpendicular to your thumb. This is your thumb. This is your four curled fingers. And make sure that they act at 90 degrees. Just like here. Here it's 90 degrees. Can you see that? Open up your curled finger. Open it up. And then it will point like this, your curled finger. Because of you wanted to follow the direction of the current. Remember, you didn't care about the curl. You didn't care about the thumb. You were only being directed by the current. How does the current move? So it showed here you're supposed to go in, there you're supposed to come out. Automatically, the curl finger will point in this direction. But if it was other way around, if the current was moving like this, here it was moving up and then down, you will see your curl finger was going to point in that direction. That's very important. So where your thumb, not your curl finger, sorry, your thumb will point in that direction. So where your thumb is pointing, it is actually pointing to north all the times. Where this part is pointing to north. So that means in this case, this solenoid on this side is going to be north, since well the thumb is pointing in this direction. So if this is north, that means that part will be south of a solenoid. Did you get what I'm saying, or should I repeat?
I get what you're saying.
I hope you're doing it practical, assembly.
I am.
Okay. So let me go back to my beautiful drawing again. Here the current is moving like this, right? So we said here at the top is moving down, at the bottom is moving into the page. Meaning here is down, 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 down. I don't know if this makes sense. Let me use this picture because I struggle to draw this thing. So let's say this was like this. I'm changing everything. Ne? Let's say this was like this. So that you can see north and south can also change as well. So let's say this arrow is now pointing in this direction. And then this one is pointing downwards. God, is pointing downwards. Right? It's pointing downwards. So that means here it's positive terminal and then there's negative terminal. From positive to negative, the current will move like this. Here will move up. And then there at the back will move down. And then here will move up. At the back will move down. At the back will move down. And then appears here, it moves up, down. It moves up, down, up, down, up. Right? I'm changing the directions. Down, here will be up, here will be up. So in front will be up now. Right? And then it will move it down and it appear this side. Right? Right? It's moving. This is a positive terminal. It moves up. Then it goes down at the back and it appears here. It moves up, down at the back, up, down at the back, and it appears here up, down at the back, and so forth and so forth and so forth. And here's gonna be up, down at the back, and then until we're changing the directions now. So now let's talk about the curled fingers. Remember, the curled fingers is current. C for current here on the solenoid. So your curled fingers, you're gonna put your curled fingers here and then wrap those curled. Oh no, up or there is going. I get there. It's going into the page. Into the page. This side is gonna be into the page because you see the current is moving up and then that goes into the page. It disappears there into the page, so it goes into the page at the top. It goes into the page, into the page, into the page, and then it's gonna appear here so that it goes up again. So here it's gonna be out of the page. It's gonna come towards you, out of the page, out of the page, out of the page. So when the current here, it is moving into the page, and then here it's coming out of the page. Where are your curl fingers? Meaning your curl fingers, they're gonna wrap on this nail like this. Your curl fingers, they're gonna come here and then they're gonna wrap like this. So that means your thumb will face in this direction. Let me see if I can, let me see if I can try to tilt this picture once more again so that it makes sense of what I'm talking about. Think. 2, 3. Yeah, I think this is it. So, yes, it was moving out of the page here, remember, from that solenoid. It was moving out of the page, out, and then it was into the page, so meaning your hand will go into the page there. Your hand will go into the page on this side and will go come out. You see those fingers, they're gonna come out here and then they wrap along that solenoid. So automatically look where your thumb is facing. Your thumb is facing in this direction. So if your thumb is facing in that direction, if your thumb is facing in that direction, if your thumb is facing in that direction, that means the north side will be here. And automatically the south side will be there. And then according to our ATP, the solenoid is covered. So what is left? We're gonna have to do these ones over here. So do you have the questions?